get D on this page. So we did find our growth factor over here. We figured out that this was growing at 3.465 every T. That's what the growth factor tells us. So our, just pulling this over from A, was 3.465. When we're writing these equations, B to the T, or 1 plus or minus R to the T. So question B is asking us about the rate. What is the R? What percent is this growing? So what we found was our growth factor, this chunk. I want to know R. How could I figure out what R is? Say it again. Cheese it? All I'm thinking of is like old school Family Guy meme. Cheese it.
You want to know what I did?
What'd you do?
The first I took the 118,000 that we had, divided it by 3, and then converted the years into months, and then
Oh, you're on part C still. You're on part C. I'm on part B right now. I just want to know what the percent of growth is for the yearly change.
No, that's how I got it.
Okay, you set it up. Then you're doing the A part, most likely.
No. So, let me write this down.
I would love for you to write it down so you could show me. Oh my gosh, what? Yeah. We're just trying to figure out what the heck has to be added or subtracted from 1 to make 3.465. Well, clearly since it's bigger than 1, we know we're going to add. So we're going to take our 2.465, and that's our R. This is what our rate is. Typically, we write rate as a percent. Guys, my turn to talk. So this is growing at 246.5% each year. So this is our rate.
That's how it is.
Yeah, that's the monthly rate. That's not the yearly, not the 246% here. You did that one. You're on this one. So hold that thought for 2 seconds. Yes, for part C, not for part B.
I didn't even see part C.
That's what was on the board.
Oh, and that's why.
I know. So you can set this up as an equation. I want to know when this guy equals that guy. When those two things equal. I want to know when our 3.465 equals our 1 plus R. Solve it. Get to an R equals 3.465 minus 1. That gets the same thing. So our rate for how it's growing is 246% every year. So the big question I asked, the longer question, was how did the snail population grow each month? We're not just going to take our base and divide it by 12, even though it's very, very tempting. It's not quite right. So on one like this, and I saw those of us that were actually working, for the most part, does set this up right, where we'd set this up the exact same way we did for the first one, where we started with our 18,000 snail, or wound up with our 18,000 snails. We started with 3. We're figuring out what our base is. But what is our power for this one if we're looking at months? We're looking for months. How much time did it take? 7 years. How many years, or how many months in a year? 12. So every year we'd have 12 months. So we could take our 7 times the 12. So what is our power on this really? 84. Luckily, we have calculators, and there's in fact one on the table. About 4 inches from your hand.
I'd say that's more like
Oh, woe is me. It's a whole foot away to reach it. I have to slightly bend to reach it. Oh, Oh, the strain.
So full.
I know we are checked out and senioritis is a thing. We still got a whole chapter to go, y'all. Luckily, it's a pretty chill chapter. It's very relevant. Real life things. This is a for real thing. So we can go about solving this 100% the exact same way we did on the last one. Start by dividing it by 3. That gives us our whoa, chunky pen. Our 6,000. B to the 84. Ew. But the same way we did it for the first one, where I went and found my 7th root, we can get our 84th root. It's unpleasant, but it's a calculator thing. I can take my 84. We're going to take our any root, bless you, of our 6,000. We can type it in the calculator. I want to unpower that 84. So we get 1.109 as our base. So what is the rate? What's our percent rate? What's our R? So now we're doing the part B part.
109.
Yeah, so this is our growth factor. I'm just going to call it GF. That's our growth factor. To get our rate, that's when we're saying what happened to this 1.109 when we had it as 1 plus or minus R. I want to know R. So since we had bigger than 1, we're subtracting 1 from both sides. So our R is that 0.109. We subtract 1 minus 1. Which means our rate as a percent, our growth rate, was 10.9%. So the population grows by 10, almost 11% every single month. So month 1, there's 3. Month 2, we're up 10.9 from there. Month 4, we're up 10.9 from there. So we could write an equation for this one, for our snails, the amount of snails we have. We're still starting with those 3 snails. And we have our 1 plus that 0.109, because we put it as a decimal, to the months. So what I want you to do, and this is our last bit for today, see how many months it would take for our population to double. You can either set it up as an equation, but that will require you to remember some log stuff from algebra. Or you can do a guess and check situation. Plug and chug. It will be within the first year. You'd have up to 12 that you have to try. When will our population double?
Is it within the first year?
It is within the first year. Okay, so take a look at that and see what we can figure out. It's like if it helps, you can always give yourself a little sketchy sketch. We know we're starting with our 3 snails, and it's going up. So think about what we want it to equal when it has been doubled.
The number of snails?
The number of snails. If we start with 3, think about what you're looking for.
Okay, done.
Tuck it in your pocket for a second.
It's ironic.
Why am I listening to this?
Yes, dear.
What?
So you're gonna need to do, hang on, don't distribute through right here unless you're doing like your month 1. So you can just type in the calculator and just put in 1 for M or 2 for M and go from there. So I'm gonna put this up here as a graph. This is a 1 plus 0.109 to the X. Settings. Oh, I can change my color. But I can't make the lines thicker. I don't like that. Cool. I like it stay.
Am I wrong though?
No.
I'm not about to do months, days.
What's up?
So I'm not about to do days.
No, I'm not either.
No, I have to because you're saying it like that.
I won't be able to tell you what you write. Not a thing we ask typically.
Correct, we're not including gap years.
No. Getting extra with it. Shock, I mean. So if we type these things in the calculator, we're gonna start to see some stuff. If we look at our month equation, that's the one I've put in up here. I put our month equation. So at 1 month, if you type it in your calculator, we will have a little bit more than 3. So it's a decimal thing, and yet even though it's, you know, living creatures, we can still say it's about 3.5 or almost 3.5. At month 2, if we put 2 in for our power, we're gonna be up here at about 3.5. If we put 3 in as our power, we finally breached 4. So it probably looks like about 4.25-ish. So what are we looking for? What will it equal when we've doubled our population? 6. So we started at 3, and 2 times 3 gives us 6. So how many months does it take for us to get to 6? Yeah, almost 7 months. Between month 6 and month 7. So if you're typing it in by month, the first time we get past 6, more than double, you would have to get all the way to 7, because at 6, we're at just over 5.5. So month 7 is really when it doubles. So every 7 months, the number of snails is doubling. So at 7 months, we have 6 snails. Another 7 months, we'd have 12 snails. Another 7 months from that, we'd have 24 snails. So they're doubling every 7 months. That is a lot of snails. Look at how quickly this grows. And remember that it's counting in months. So 24 months, which is here. 24 months being 2 years, there's already about 35 snails. So if we want to see when they hit 100, That guy right there. Oop. Let me tap. Oh, good. To get to 100 snails, we're right about 34 months. 33, 34, somewhere around there. Which is less than 3 years till we have 100 snails. But then look at how quickly it went back up to 18,000, because remember, within 7 years, we were at that 18,000. Look at how quickly that grows. So these exponential problems, once they get big, they start growing real fast, real quick. At the beginning, they're kind of slow. But once they get cruising, they are cooking. Okay? So I encourage you to think about the last 2 bits on here where they talk about the cost of it, but I more wanted to focus on the finding the pieces that we need, finding our growth factor versus finding our growth rate. Factor and rate are going to be those things we focus on a bunch, that we deal with lots and lots and lots of times between growth factor and growth rate. Okay, so we're going to talk about those kinds of things and start looking at things that get a little bit decimalier and kind of gross starting tomorrow. So we have about 5 minutes left. So if you did not do either homework 2 or the e-learning, which was the exact same thing, now is a great time to do it. I only have like 3 more homeworks this semester. And that's if I'm not forgetting any. Okay, we only have 27 more school days. You have 27 more wake-ups left in high school. 27. That is not very many. So, yeah, those of us that are seniors, we have 27 more high school wake-ups. That's it. That's doable, as long as we don't check out. Please don't zombie out on me.